Something unusual is unfolding in the quiet darkness of space, just 4.2 light years away from us. That's incredibly close on a cosmic scale, practically our backyard in the universe. Astronomers monitoring a nearby exoplanet have detected something unexpected, a strange, persistent light pattern coming from a place we've been watching very closely, Proxima b. This isn't just a blip or background noise. It's a structured signal unlike anything we've recorded before, and it's challenging our understanding of what's out there. The question immediately arises: is this a natural phenomenon we just don't understand yet? Or is it something more? Something potentially artificial? You've likely heard of Proxima b before. It's one of the most famous exoplanets, precisely because of where it is and what it represents. Orbiting Proxima Centauri, the star closest to our solar system, Proxima b sits in what scientists call the habitable zone, or the Goldilocks zone. This is the region around a star where conditions might be just right for liquid water to exist. Not too hot to vaporize it, not too cold to freeze it solid. And that's only the beginning. What really grabs scientists' attention is that Proxima b is nearly the same size as Earth. That alone raises a tantalizing possibility. It might have a rocky surface and a solid ground, just like our home planet. It's not just floating gas, or an icy giant. If life were to exist somewhere beyond our solar system, a planet like Proxima b, so similar in size and distance from its star, becomes a prime candidate. But there's a twist. Several, actually. Proxima b orbits a red dwarf star. Red dwarfs are small, cool stars, much dimmer than our sun. Because they don't produce as much heat or light, any planet in their habitable zone must orbit extremely close. In the case of Proxima b, it completes a full orbit, its year, in just 11 Earth days. That's astonishingly fast. It's practically hugging its star, and that close orbit brings with it serious complications. First, it's very likely that Proxima b is tidally locked. That means one side of the planet constantly faces its star, basking in unending daylight, while the other side is forever cloaked in darkness. Think about that for a moment. One hemisphere scorched by continuous solar radiation, while the other is plunged into eternal night, cold and frozen. The only area that might offer a survivable climate is the narrow boundary where the two sides meet, a slim twilight zone circling the planet, where temperatures might be moderate enough for liquid water to exist, a thin strip of possibility, caught between extremes. This alone would make Proxima b a subject of endless fascination, but it doesn't stop there. The planet's host star, Proxima Centauri, may sound gentle, but it's far from stable. Red dwarfs are known to be volatile, and Proxima Centauri is particularly active. It frequently unleashes powerful solar flares, massive eruptions of radiation that sweep across its planetary system. For a world like Proxima b, this means it's under constant assault. These flares could easily erode an atmosphere, assuming the planet even has one, and they pose a major challenge to any potential life on the surface. Despite all these threats, tidal, locking, radiation, temperature extremes, scientists haven't lost hope. And the reason is simple: proximity and potential. Proxima b is close, and it checks many of the boxes. Right size, right location, and just maybe the presence of water. And where there's water, there's always a possibility of life. But Proxima b isn't just fascinating because of what we know, it's even more intriguing because of what we don't know. The recent detection of a strange, structured light pattern coming from the direction of this planet has reopened a question humanity has asked for generations. Are we alone in the universe? The signal isn't random static. It's not the kind of interference we'd expect from a natural flare or a background star. It's persistent, structured, unusual. It doesn't match the typical emissions associated with stellar activity or cosmic dust. And that's why it has astronomers on high alert. Could it be volcanic activity on the night side of the planet? Some exotic weather system or an unknown atmospheric phenomenon? Or could it be artificial? Could it be something engineered, a beacon, a transmission, or a side effect of technology we can't yet identify? These are not questions science asks lightly, but they are being asked now. Studying a planet like Proxima b isn't easy. Even though it's one of our closest neighbors in space, it's still about 40 trillion kilometers away. That distance is staggering. Observing it with clarity is like trying to study a grain of sand on a beach from miles away. The light from the planet is faint, and it's constantly overwhelmed by the brightness of Proxima Centauri itself. That's where today's cutting-edge technology comes into play. Instruments like the James Webb Space Telescope are changing the game. Unlike traditional telescopes that rely on visible light, Webb sees in infrared, perfect for studying cooler objects and peering through cosmic dust. Soon, the upcoming extremely large telescope, armed with an advanced instrument called Harmony, will join the search. These tools are helping scientists do what was once impossible: detect the chemical signatures of distant worlds. By analyzing the light passing through Proxima b's atmosphere, if it has one, scientists can look for gases like oxygen, methane, carbon dioxide, or even industrial chemicals that don't occur naturally. Some of these, like methane and oxygen appearing together, could be strong indicators of biological activity. Others, like certain chlorofluorocarbons, might hint at something more: the byproducts of advanced technology. But still, the planet's harsh conditions remain a hurdle. If there's life on Proxima b, it would need to be extremely resilient. It might exist underground, shielded from radiation. Or it might thrive in the twilight zone, where conditions are more stable. Or perhaps, if it's intelligent, it has found a way to adapt, to survive, maybe even to communicate. And then, of course, there's the mystery of the signals. They seem to be coming from the planet's dark side, the hemisphere locked in endless night. The emissions don't match any known natural process. Not solar flares, not background radiation, not auroras. They're different, regular, persistent. It's tempting to imagine a civilization on the night side, using technology to light and heat their world, or perhaps sending signals into space. We can't jump to conclusions, but we also can't look away. Scientists are now keeping a constant watch, turning their most powerful instruments toward Proxima b. Every new data point, every faint signal, every unexpected flash of light is analyzed, debated, catalogued. One day, perhaps, we'll send robotic explorers to its orbit. For now, all we can do is observe from a distance and keep asking the question that drives us forward. Because Proxima b isn't just another exoplanet. It's a puzzle, a mirror, a potential glimpse into another kind of life. If there is life there, whether it's microbial, complex, or even intelligent, it would forever change the way we understand our place in the universe. It would mean we're not alone, and even if the signals turn out to be natural, that doesn't make them any less valuable. They're teaching us. They're pushing the limits of what we know, forcing us to develop better tools, ask deeper questions, and explore farther than we ever have before. The quiet light coming from Proxima b could be the beginning of something monumental, a clue, a spark, or maybe even a first contact. Because somewhere in the cold glow of a distant red star, the truth is waiting. And we're getting closer, one signal at a time.